Hey folks. Hey everyone, this is Jatin, and today, first of all, thank you, Kalyan, for starting us off on a great note, and thank you everyone on coming in on a Saturday evening and joining us for this session. So I'm actually getting a message from AirMeet that my internet connection might be unstable. So let me know if you guys see any trouble, and let me know over in the event chat, session chat, if you have any trouble hearing or seeing my video. All right, I think we'll get started.
We can hear you well, Jatin, if it is okay.
Okay, thank you, Sanjit. Great. All right, so first off, like as Kalyan was also saying, I want to just continue a little bit over there. We really want to invite everyone to submit their talks. Like if you have any proposals, be it for a TikTok or like any session you want to take, or a workshop, tutorial, anything at all, we welcome your proposals, and we would love to get some more proposals from your end and organize a meetup with those proposals. So feel free to submit your proposals on our CFP link. And moving on, the meat of the talk, what and why should you care? Let me just switch over. I hope everyone can see my screen. I'll actually not be presenting in full screen mode. I'll just present it over here. Earlier. Yep. So what is today, like, as part of this talk, we'll mostly be focusing about what is OAuth 2.0. Starting from the first thing we'll be talking about is the difference between authentication and authorization, and how did OAuth evolve from its initial draft to OAuth 2.0? What is how does it work as a protocol, and what is next in OAuth 2.0, and why do you need to care about authentication? So, just one disclaimer: this talk is not intended for like preferring one, like promoting one over the other. It just intends to make sure that everyone understands the subtle difference between authentication and authorization, and you get like making everyone aware so that they can make informed decisions on what they have to choose, how they want to implement it, and just like the whole crux of this talk is to make sure that you guys have enough information to make informed decisions when working on security for your applications. Okay, on first thing, let's just briefly talk about a traditional client-server authentication model, where let's say if you go back sometime or like anything at all, like mostly what we used to see was there would be a server that will be running, and your client could be like, let's say, your browser. From your browser, you just send a request, sends the login details, that is the username and password. So a server just creates a session on its side and then sends the session ID or something in the cookies that notifies that this user is authenticated, and that cookie is sent to the client. So client, after that cookie is received, it will server will redirect, let's say, to the dashboard page, and then if user wants to do any operation, be it like, let's say, get user profile or load some view or any operation on the application, they'll send a request from the browser to the server, which will also include the server session ID cookie. So if that cookie is missing, server will say that this user is not authenticated, and it will redirect that user back to the login page or sign up page. So that's how the traditional architecture was, mostly like you authenticated using your plain text credentials, username and password. Server store created a session on its end and just gave you one cookie or like some identifier. It could be token as well. And then using that information that you receive from the server, you make subsequent calls to the server again, and then server validates that token or the cookie, and based on that its authenticity, it will return the success response. So this was like just authentication, that you have some credentials, you're authenticating yourself to the server that I'm a valid user. You just gave your username password. Now we talked about let's say what are the challenges. First of all, we all understand it's pretty easy to implement. You can write your own data, like simple, pretty simple, because you have to store the information on the server side. Client will just send their credentials, and mostly all the processing is happening on the server side, be it cookie generation, like user validation, cookie generation, cookie authentication, cookie validation again for latest requests. But the challenges with this approach are that server could be storing a password in plain text. So you really have no idea when you are making a request to an application server, you really have no idea how the server is storing your credentials. It could be possible that it's storing those credentials in plain text in the database, but they are just saying that we have enforced security on the database itself. But still, you have to understand that database, even though you have secured your database, there is still a possibility that if something goes wrong, your credentials were stored in plain text. That compromises your overall application security and the trust that you have formed with your clients, that is your customers. Then there is also a possibility like HTTPS was enforced recently, like not too long back ago, but before that everything was over HTTP. So many things were on HTTP, and people were transmitting plain text passwords over HTTP, like possibly insecure network. Let's say you are connected, you are at an airport and you need to do something important, and if it was running over let's say even though it was HTTPS, there is still a possibility you are connected to an insecure network. So that is also one of the risks that is added with the traditional approach. The next thing is authentication is not reusable. Let's take a step back and we have to understand it deeply. What do we mean by authentication is not reusable? You authenticated yourself, let's say, to google.com. You cannot use the same authentication over to facebook.com. When you go to facebook.com or xyz.com and you create a new account, you give your username, you fill the sign up form where you provide your email address, password, and everything. So that means you have two different websites with two different credentials. It could be the same credential, but you're basically not able to reuse that same authentication from one application to the other. Same logic applies, let's say, when you're building a multi microservice architecture, that you have tens of microservices, let's say, and you have like you can't you really don't want to end up in a situation that user will have to sign up on each individual service to be able to use that service, and that is the limitation of authentication. And so this is what happens, like the second part of it, that if you have like too many applications that you want to sign up for, most of the time the people will end up using the same password, same username password across different websites or different applications, or choosing less secure passwords so that it's easy to remember, easy to update at any point of time. That really compromises your overall security, because here that makes you prone to social engineering. That is, a person who knows you pretty well, they can guess your, let's say, birth date and then make some estimated guesses and could possibly hack your password. So that just risks you to social engineering attack. Then next thing is there is no cross authentication between the server and the client. The client just says that I'm just sending a request to this server, but client really does not know whether this server that I'm sending the request to, whether it's a valid server or a system impersonating as that server. So it's more like phishing attacks. That's how it used to happen. If you predate it a little back, people will receive emails. They'll get a form from they're like sign up on Google. You need to log into your account to view this offer, and they'll land up on a phishing page where it will collect which the page will look same like a Google login screen, and they'll enter their credentials. That screen will then that system has captured your credentials. It will redirect you back to the Google server, the actual real Google server, and there it will ask prompt you for login again, and which will really not make sense to you. But by the time you realize it, your credentials have already been transmitted over to the malicious attacker. So what are the before I move? So what are the these are the limitations with authentication or like traditional approach. Even though you can authenticate yourself that I'm a valid user, but you really don't have a way to know whether you authenticated to a real system or a fake system. So coming on to OAuth. So December 4, 2007, IETF Internet Engineering Task Force, it released its final draft for OAuth implementation. And that time it was just known as OAuth. Later on, came OAuth 2.0, and this one is more commonly known as OAuth 1.0. So it just what happened was like it introduced a third role. We saw that there are two roles, client and a server. So OAuth basically introduced a third role to this authentication client server authentication model. That was the resource owner. So this quotation is directly from the IETF draft. The client, which is not the resource owner, but is acting on its behalf. So client is actually not the resource owner. Client just requests access to the resources. So server has a server is just like a validation layer that it can authenticate whether this client is valid or not, right? Resource owner is the one that actually holds ownership on those resources, that whether this client should be able to access this particular resource or not. So what happens is client is requesting access to the resources, but hosted by the server. So hosted by the server, basically like the request will go, you cannot directly connect to the resource owner. You can only go via the server. So the server will validate both the client and the resource owner and the identity of the client. So you're basically giving an access to a client that you can access these resources for a specific period of time using this specific token. Moving on, I think this one will make it more clear. So process where users grant access to their protected resources. Server has multiple resource owners, and server can have tens of thousands of users, right? Each user has his or her their own resources. So what OAuth authentication process does is user comes in, they grant access to those resources, and they are with the consumer. That is like the consumer could be some application, let's say. This application, you granted access to these protected resources, but this application is not connecting to the server using your credentials. Client is the only one who connected to the server using those their credentials, the username, password. They authenticated this application, and application server will see that this application has been authenticated by the client or the user. It will return a token. There is the request token. We'll get to the token types. So that token will go back to the application. Application will use that token to make request to the resource owner via the server. So server will receive that token from the application. It will validate that token, check for its expiry. If everything checks out it's validated, it will grant move that request to the resource owner. Resource owner will then grant that token also has the scope, like how many resources does this token should have access to. Based on that, it will access the resources and then return those resources or that information back to the client, back to the application. So I think I moved a little fast. I'll just jump back to the AirMate console. Let me know if you guys have any questions in the chat before I move on. Okay, moving on. So there are two types of token for OAuth or OAuth 1.0, request token and the access token. So request token is just used by the consumer. That is our application which asks the user to authorize the access to protected resources. So a request token is generally, let's say, generated by the application, that it goes to the client that, hey, this is the client that I'm telling you, I need access to your resources on this server. Client will then redirect, the browser will redirect to the server. Server will say that whether you want to authenticate this request or not. Based on that request token, when you say grant access, it will generate an access token and return it directly to the application. So used by the consumer, which in our case, I'm just referring to our application. And it is accessing that protected resource, but not directly as the user, but on behalf of the user. So this is how the overall authentication flow looks like for OAuth. Consumer, they receive a request token, they request a request token, and then service provider, and in this case it could be the application, they grant a request token, direct user to service provider, then obtain so that application will show a consent screen whether that this is the application, this is the scopes that it is this is the access that it is requesting to these kind of resources. Then once the user says like authorize, then direct user to consumer, where it will like using that request token and authorization, it will request an access token from the server now. The server will grant the access token, and finally, we can access the protected resources by using that access token. So consumer obtains an unauthorized request token. It's just like a random token. User authorizes the request token, and consumer finally exchanges that authorized request token for the access token. Now we have seen that how it added like another layer of authentication, that you're accessing the resources but not directly through an application, and that application also is not using your credentials directly but using a token. But it definitely had its own limitations where it worked for, let's say, web applications. But by the time it was rolled out, we saw a lot of shift towards smart devices or mobile devices. So mobile devices and or let's say limited input devices, which could be your consoles, gaming consoles, or smart TVs, or printers. Let's say, right? They have limited input. They are basically limited input devices. So it did not solve the problem for all those kind of devices. Then came in OAuth 2.0, which was actually a complete rewrite of the OAuth 1.0 from ground up. So, but sharing the overall goals and general user experience will remain the same, and it worked for all non-web clients as well. And it's more like it was built on top of OAuth 1.0, right? So it had the experience that it gained from the exposure of OAuth 1.0, and then solved those complexities. Also added it for considering for non-web clients as well. So now it has defined four roles: client, authorization server, resource owner, that remained the same. Then it added a resource server as well. So what happens in general, like let's say there are multiple ways to authenticate, right? I'll just for this for the reference of this talk, I'll go back to Google OAuth Flow a lot of times. So Google, right, it supports 5 ways of authenticating using OAuth 2.0. One is server-side apps, where you can create like you have your own application, be it let's say Flask, Django, or JSP, any kind of web application where it's running on your own application server. And that application you want to do some operation, let's say on Google uses some inbox or like some other API that you want to use, right? So what it does is like your that server-side apps that you're giving creating an OAuth 2.0 app, and you'll create so you'll basically have that login with Google or sign up with Google on your application. It will redirect to Google servers. Once you grant access, based on that, it will return an authorization code. Use that authorization code for making the second exchange, which is getting the access token and refresh token. So just a short example, let's say I'll just go to meetup.com. So login. It just it has its own authentication as well. Like you can sign up using email address and password, or log in with some other social services, be it Google, Facebook, and Apple. So let's say Google. First thing that it does is it checks that there is no user logged in. So let's say actually it won't show me that access. So this is what I wanted to show you. So first thing that you see, right, that this is the access that it is requesting. Like this is the application that Meetup has created, and what it is saying, like this is my developer information. Signing in will redirect you to this page, and to continue, Google will share your name, email address, language preference, and profile picture with Meetup. So when we create any OAuth application, right, we need to define like what are the scopes for that application, what kind of information we'll be requesting. So I'll come back to this part a little bit later. Moving back to the presentation, so coming back to authorization code part. So what happens in this kind of request is your first request, you go to your application server, let's say you clicked on login with Google, it redirected you to the Google auth screen, sorry, Google login screen. So there it sees that you're already logged in, you have this server, and then it shows you the application info. That is that this application that has been created by this dev and all. This application is requesting access to these of your resources. So in this case, we saw name, email address, and name, email address, language preference, and profile picture. So this is the kind of information that it is requesting. Once you log in and say you say grant access, what the OAuth 2.0 flow will do is it will generate like, since it's all happening on the Google side. Google is the authentication provider in this case. So since we are logging into Google, what we'll do is Google will create an authorization code for that application. It will send that authorization code to your application server on a callback URL that you should have defined earlier. I'll show you how that application looks like. So while this happens, I'll also be showing a demo shortly, which will where we'll see all the steps, each step one by one, and how that authentication like transaction happens, how the code control flow looks like. So basically, we are telling like the grant type is authorization code, the code that we had received from Google. Let's say in this example, the redirect URI. What is the redirect URI for that application? Client ID and client secret. So first, I'll show you how the application looks like, and like a OAuth 2.0 application on Google side. So first thing that we'll have to do is like just a name and what is the URI, like authorized origins, like where that request, if a request comes in from this source, only then authenticate that request or honor that request. Otherwise, reject all the other requests. And then what is the callback URI? So callback is actually, let's say once user has authenticated that, yes, I want to grant access to this application to, for this kind of scope, it will say that this it will make a callback on your application server on this endpoint. So auth-callback is what I have defined in my application, and there it will return make a callback on that URL with the authentic authorization code. So using that code, I can then make a second exchange, which is to get the final access token and refresh token. So this was like a general flow. And then let's look at the flow over here. Authorization request goes into authorization resource owner. So first, let's just focus on the left part, and we'll come back to the right part in a bit. So this is like abstract protocol flow is when it is happening for the first time. So the request goes in, resource owner shows you the grant page. So we see that this application is requesting access to these of the resources. Then client, that is our browser, clicks on authorization grant, that I want to authorize this application. That request will go to the authorization server. It will return us the grant actually includes that authorization code as well. It will get us the access token. Then the client will make further request using that access token to the resource server and get the protected resource. Now, what makes it different? So username and password, it's more like you have it ready till the time like those credentials are activated till the time you actually go in or change those credentials or just delete your account. But with OAuth 2.0, to add an additional layer of security, it adds a expiry to each access token. So many applications follow default expiry time of 6 hours. Getting an access token for the first time involves some user intervention as well. That is, you have to go to your web browser, authorize that application, grant access, right? But what happens, like you really don't want to for a better user experience, right? You don't want users to come in and authorize it over and over again. So what OAuth does is it has a second type of token, that is a refresh token. So refresh token has a longer validity, and using that refresh token, you can just let's say, coming back to the second image, refreshing an expired access token. So you made your authorization grant. We see that we got an access token and a refresh token. So let's say we were using that access token to get the resource, but as soon as the token was expired, we can now send in that refresh token and get a fresh access token. And based on the implementation, OAuth implementation on our server side, and like be the identity provider, we can either send the same refresh token or update that as well. So this is how the flow looks like. User, they enter a URL, they go to the browser. The browser will open the client app, that is the web server of my application. It will start the OAuth process. The request will go to the open the redirect URL, that is like authorization URI. So Google, let's say we went there, it showed us that whether you want to authorize this application or not, and then the browser will show that to the user. User will present their credentials and authorize or deny. Present so based on that authentication, like their response, it will send that to the authorization server. It will verify those credentials, verify the user against the auth application that is created, and then create an authorization code. So this authorization code, it will redirect to the web server with the authorization code. So now this exchange is actually like it came, the request came to the browser, but it is actually first intercepted at the web server level, right? So browser will only render what the client app will show, right? So client app, it will intercept that request. In the backend, it will just present. So this exchange, right? This really need not happen. Once the authorization code comes to the client application, it can present the authorization code on a second endpoint, like make a second API call to authorization server, and that API call will validate that authorization code and then return us the access token and the refresh token. Using that access token, then finally our web server or our client application can finally access the resources using this access token. Right, let's move on to a short demo. So we already briefly talked about how OAuth Flow looks like. I have prepared a small Django application over here. So to cover everything, let me just start it. And this is already pushed to a GitHub repository. You guys can follow it along after later on as well. And the instructions are already part of README. To make it simple, I've Dockerized this entire application and just like made the steps in Makefile as well. So just need to run make all. It will launch all the services. Remember, I'm launching this app for the first time right now. It's creating all the containers. It just did all my user models migrations as well. I have, I'm running it on localhost. This directory on localhost 8080. So let's say, and it's just a simple blogs application. I haven't just wanted to show you the authentication part. So let's say I do sign up and I give. So based on like how I want to implement, it's up to me because it's my application. I can set up a password limit, like what kind of password you want to set, and all sorts of validations, right? So let's say I have signed up. Now, when I signed up, this basically is like a simple page. I'm just showing that this is the username, name, email, phone number. So just to show you the overall idea how sign up and login would be like, and I'm just setting a session, one cookie in the session, that is the username. So if username is there in the session request, then it will go to the blogs. If I try to go to the blogs endpoint directly, it will redirect back to login. And let's see. So that works. And this basic authentication, let's say some random username, no user found with the given username. Invalid password does not match. So let's say something basic, right? So now this was the authentication model that I was talking about. Now it's up to me how I want to implement it on my side. In my case, I have just created two separate tables, one for storing the user information and the other for username and password. Where password, I'm encoding it one way so that anytime user is setting up any password and like giving up anything in the input form, I'll just encode it with the same salt. Each user will have a unique salt. So that's what it's up to me. Like it's up to the developer team implementation how they want to set up authentication on their application. Coming to the OAuth 2.0 flow. So let's say login with Google. When I click on this, I have already. So let me go back to the application. I'll just show you this JSON file. So when I already show you this application, right? But this is the client application that I had created on OAuth 2.0 screen. So I have a client ID that is created, a client secret, and I can just download that JSON, which will have like what URIs of the origins are accepted and what is the callback URI. So this one is also having that same information, the client ID, project ID, like I have created a project on Google Console, the authorization URI, token URI, and certificates, client secret, what are the redirect URIs, and what are the origins that it should accept a request from. Using this, what I do is I create an application. So I'm just using the Google API Python client. So setting up that flow from client secrets file, giving a path of that secrets file. And when I created this application, I'm just coming to this part now. We already saw that these are the credentials that I've created, but what we just created these as credentials. We need to we are yet to create our application on Google side, right? That this application is going to request this kind of access. So this is the application that I had created, Python Django OAuth, and this actually comes under OAuth consent screen. And so if I look at the scopes, so just like user support email and localhost, authorized domains, developer contact information. So these are the three scopes that I had associated with that application, that I want to get the user's email address, see their personal info that they have made publicly available, and open ID. That is, if I want to use their personal info for sign in, right? So these three same scopes, I define it over here as well, and create my flow, redefine the redirect URI. That Okay, I actually had authorized this application earlier, so that's why it did not show me that request. So I'm actually, you don't need to show this all. I'm just doing it step by step. So to make sure that everyone understands the overall flow. So what happens is we just say that user has authorized the request and application has received the authorization code. So if you notice, let me just copy it over here in the editor. Right. So let me break it down. And before I even go there, let me this URL also. So notice the first one. The first URL is actually where we go to the Google server to the authorization. So and response type we have defined it as code. Client ID, it is passing it from the JSON that we have. So it is passing the same client ID, and it is also passing the redirect URI and the scopes that I have requested. So what application does is it is also adding another layer of verification. That is, if the redirect URI does not match or any of the scope does not match, it will not give me the, it will show me an error during login itself. So let me do it over here. That I'll just remove the scopes, all of it. Now let's go to this URL, invalid request, missing required parameter scope. Let's say we don't want to remove all the scopes. We'll just remove fill here. Some scopes are still there, so let's see what happens in that case. Yeah, so basically it's saying like we'll redirect you to this, and I'm just omitting one character, two characters from the redirect URI. So if let's say what happens if someone tries to change the redirect URI does not match with each other. So what you passed from the your application and what was defined on the server side. So on your OAuth application, it does not match, so it will fail that request. So this adds an additional layer of security. That is, if someone tries has abc.com, but if they try from xyz.com, the redirect URL will not match, and it will raise an error over there. Moving on, now we have already like the callback URL, callback has come to our URL that we had defined, and now we have received the authorization code. Now what happens next is we exchange. So again, I intercepted this request over here on this part alone. We can just like on our backend side, we don't really need to have an endpoint for all these. What we'll do is even for callback also, we don't need to have a UI to display anything. We'll just intercept that code, make a backend to backend call to, and then exchange it for authorized access token, and then finally use that access token for any other further operations. So then I exchange that authorization code for the access token, and this is finally the access token that I've received. Now remember, I have only received the access token. I haven't received any other user information or anything else, right? So I have to make any further API call to Google server to receive any information about this user, like who this access token belongs to. Okay. Production. Okay, so I did the exchange and make any change on the code side, but just something that I had a small one. So I just got the user info using that access token. I just made a call to the people API for on Google side, got my name and email address, and then just showing that same information over here. These times we are integrating our applications, our own applications with some other third-party applications. So whenever you're, and similarly, there would be a possibility that you're writing some application that you expect some third-party users or like some other applications want to access your data. So you cannot really give your access out there that you can just connect using your username and password and then have the full access to your resource server, right? You cannot expose your resources directly. So what happens is with OAuth, you're adding an additional layer of security. That is, if you deploy OAuth on your applications, and if some third-party application is requesting access, first thing you'll have a layer of verification that the origin matches or not. If origin matches, does the redirect URI matches or not? If the redirect URI also matches, does the scopes also match? Is he trying to request something that I haven't really defined that scope in my OAuth application? So I can, that is my first barrier. After that, once everything is validated, it will, I'll still like user, I see that user is, sorry, this request is valid. I'll show it to the user who has generated that request that please enter your credentials on my application, that whether you want to authorize this third-party application to grant access your data or not. So once that happens, I have granted access, then I generate a token and return that token. So I've only restricted it to 6 hours, let's say the default one. After that, if you still want to request, and then user can, one big thing that I wanted to point out, so something that happens is if you have shared your credentials with the third-party application, you'll still have to go to the third-party application and remove a request to remove those credentials. Now that is under the let's say privacy or like security policies. But what with this authorization, right? So let's say authentication, you have same credentials across 100 websites or 100 different applications. Really, it's a cumbersome process that you go to each individual application and get those credentials removed or delete your accounts individually. But with OAuth, what happens is you have single control, and on your single application side, you can go to that application dashboard, see all the integrated applications or the applications that you have granted access to, and revoke them at any point of time. And it will just stop the flow from the application side, from the resource owner side. Now, the other things is, let's say one more thing, Google is actually planning to remove the less secure apps option. So I don't know if any of you have ever tried to do any operations on Google APIs. And when you, let's say if you want to implement it with your own IMAP service, you want to access your mailbox. And if you want to directly access your mailbox using basic auth, that is username and password, you have to first disable allow less secure apps. So Google is actually removing that for G Suite and enforcing all applications to just go via the OAuth Flow, because that is more secure and that avoids all these complications. Microsoft and many other big organizations are also following the same. Then another thing is like it really makes you focus more on the application and core functionality. So a lot of businesses have come up as with a new area, that is identity as a service. So you can really focus on your application side rather than access and authorization management or security and other things. So Google is also acting, Google, Apple, Facebook, and Auth0. These are four of the major players who are doing identity as a service. That is, you can use their applications to provide your identity to some other third-party applications. As we saw in the example of Meetup.com, it had support for Facebook, Google, and Apple. That is, you manage your credentials only on one application side, and using those providers, you can provide your identity to some other third-party application. And again, this is no way, like this talk is not framed to prefer authentication or OAuth over authentication or anything like that. It's just to give you a perspective so that we all can make better informed decisions. Now, a couple of latest developments with OAuth 2.0 before we conclude. MutualTLS. So we talked about that OAuth is actually doing that, but still you really don't have. We are validating the source and the destination, but still there is no proof of possession that. So MutualTLS is being worked on, which will act like a proof of possession. That if somebody, even if they steal the access token, that access token will be encrypted with the TLS certificate. So if they don't have that certificate, that access token will still be invalid. So at the current time, if someone steals your access token, even if it had 1 hour of expiry left, within that 1 hour, they can access all your resources and do any sort of operations. But with MutualTLS, that access token will also be signed, like secured with the TLS certificate. And with that way, you're actually having a proof of possession token that I'm the one who should have this access token and no other resource should have this access token. If the resource server receives any request with the same access token, missing that TLS certificate, just render that token request invalid. And then resource indicators. So mainly, like, let's say I'm talking big in terms. So let's say you have thousands of resource servers, and each resource server you want to optimize it for let's say request handling or latency purposes. So that way what happens is your data could be residing, or let's say one data center can have 10,000 resource servers, but your personal data is residing only on 3 to, or let's say 10 of those servers, right? So you really it has time to figure out like which resource server the request should go to. So now it is they're planning to add a resource indicator that this request should always go to this resource server, so that it improves the security. Basically, meaning that you should only your request should only go to those 10 resource servers and should never go to the other 9,990 servers. So that makes it secure for the rest of the data. Then there is OAuth 2.1 also that is currently being drafted. It's not yet finalized, and it's intended to build on top of OAuth 2.0. It's not a scrape and rebuild of OAuth 2.0. It just captures and consolidates those changes. So OAuth 2.0 has been out in the market for over 8 years. So they are trying to take away some of its complexities and incorporate some of the basic functionalities into the OAuth 2.1. So one of them is PKCE, commonly known as PIXE, which is like proof key for code exchange. So we talked about that authorization code could be exchanged by like once you receive the authorization code, you can exchange that code later on, right? It does not really expire. It is only a one-time code. But if that token gets, that code gets stealed over, it can be used. So they are more adding like a proof key that this proof more like a code verifier or something like that. So it just adds that we got the authorization code, but the code request was intercepted by our malicious app. So that app will actually get the grant and the access token finally. To avoid these kind of situations, it will have a code verifier as well. So state verifier is some OAuth providers call it, and that based on that code verifier, only then that code will be exchanged for the final access token.
Jatin, Sanchit here. I'm sorry to interrupt. I'm just doing a quick time check.
Yeah, I just noticed. So Just wrapping up, just 2 more minutes for this is what I wanted to cover. Majorly, like the implementation that I showed you in my this application, I was actually doing the exchange. And if you are only focused that you want to get identity as a service, that you want to use Google for authorization, or Facebook or Apple, a new standard that has recently come up, not recently exactly recently, but OpenID Connect. Using that, it returns you a cryptographic JSON sign to JSON token base64 URL encoded. With that token, it will involve your IS, like audience and all that information. You can use that token for as an identity and store a user. Like once that token is validated, you can store that username and email address in your tables. And if that user is already there in your tables, then you can just get the token for them and do the further exchange. That is like that user is already authenticated. If that user is not there, you can redirect them to sign up screens. They'll sign up using their OpenID, validate that. Once you get that validation, your application server can store that username and email address in your database, and that's it. You have validated your user. That takes away one more complexity for some of the applications. If you ever want to do email address validation and mobile number validation, you really don't have to do that because it's already coming from a validated resource, and you can just rely on that and move on and focus more on your application functionality. So I know I have already ran over time, so I'll be happy to take any questions over the AirMeet chat, or even I'll be hanging out in the lounge area. We can connect over at one of the tables.
I think we can take a couple of questions, Jatin, because I think there are only a couple of them.
Sure.
So I can read out if you want.
Yeah, I just saw that. So first of all, like how does it work for SPA? So they've asked this question: single page applications. And single page applications also has its own flow. The flow that we saw was for web server applications. So one of the two of the resources that I generally use for any of my application development with OAuth is, let's say, this is one example on client-side web applications, how you just enable your projects, enable your libraries, and then in your it has its own Google Auth library for JavaScript. With that, you initialize your connection, you give your client ID, API key, and scopes. Based on that, it will originate that sign in. Sorry. Handshake. It will initiate that request, and it will prompt the user for consent. Finally, that consent will return back to your API. Your API will again have an endpoint, right? So that endpoint will intercept that code and exchange that for the token. One of the really good resources that if you ever want to try is OAuth0. So Auth0 is actually a new organization that has come up recently, and they are providing identity as a service management solution, which provides all access and authorization management as well. And there you can create your own test application. They have a really good documentation on setting up your applications, be it for server-side applications or client-side applications. Single page applications, and using that you can try out the entire OAuth 2.0 flow. The other question is authorization code is app specific or user specific. So the authorization code is actually bound to the user as well as the application. So when let me go back a little in the presentation. We saw that this was the authorization code request, and when we make the first request, right, when we got the authorization code, we had to pass the authorization code in the body. Sorry, grant type is authorization code. Then finally the code, the redirect URI again. So it will be masked again. And then there is also the client ID and client secret that will have to go as part of that request. So what that basically means is, next time that the user is like the application is making a request, it still has to give its client ID and client secret. So that authorization code is authorization code. And one more thing. So when the first handshake happened, that is when we are requesting the authorization code. In the request query params, we had to pass the client ID as well. So first request goes in to request the author 3 matches. It will grant give the user consent screen. User clicks on grant access. Grant access will make a callback to redirect to a callback URI. On that callback URL, it will receive the authorization code. Next up, backend to backend request, which is to exchange the token. And there we'll be passing the authorization code, the redirect URI again, client ID, and client secret. So when all four values match, only then the server will return us the access token and the like SAML token is what is generated. It's for application security again, but it's a little different than OAuth. So I'm not really the best person to answer on that because I haven't explored SAML too much. And that's pretty much it that I wanted to cover. Any other questions we can surely connect over in the networking lounge? Yeah, just thinking if I have missed something or so I'll be tips and considerations for OAuth. So of course, one thing is like make all this information is only like again reiterating that we have to make a better informed decision whether we really want to spend time on authentication or authorization or like let's say first we have to understand authentication. It's like a yes or no. If you give do authentication, it gives you full access. There is no concept of scopes with authentication, right? With authorization, you have authentication as well as authorization. That is, you're giving limited scope for this authorization that only this kind of information can be accessed. So that is where it is helpful. And again, it's all about your application requirement and your decisions whether you want to spend more time on that. So it's again, it just boils down to the requirements. Yeah, Sanchit mentioned SAML is basically majorly a protocol which is primarily used for Active Directory operations. Like, let's say some applications they have their own Active Directory users. You can have like in all those applications you can use that SAML token to authenticate via Active Directory. So I would really recommend you guys read about OAuth 2.1. I'll be sharing this presentation as well as the repository URL. And in that presentation, I already have that link to that blog. See if I can pull it up right now. So that's pretty much it. Thank you, everyone.
Thank you, Jatin. And I think, folks, we'll be moving to our next session, which is from Bharat, and it is about customizing Django admin interface. So we'll be ending this session, but you'll be automatically moved to the next one, and Bharat will be taking us to that next topic. So see you in the next session. Thank you.
Thank you.
Thanks, Jatin, once again.
Thank you, everyone. See you around.